India's space journey has been nothing short of spectacular. From the triumphant launch of Chandrayaan 1, which discovered water molecules on the moon's surface, to the groundbreaking Mars orbiter mission, which made India the fourth space agency to reach Martian orbit, ISRO has consistently pushed beyond the boundaries of innovation. Now, as the world watches in awe, Chandrayaan 3 has successfully landed on the moon and the entire world is applauding for us. A mission designed to achieve what its predecessor Chandrayaan 2 narrowly missed, a soft landing on the moon's south polar region. So let's dive into the mind-blowing turn of events that led to the Chandrayaan 3 mission, the new discoveries that it is going to make, how the next 14 days is going to be some of the most crucial days in the history of ISRO, and how this mission will impact the global economy and the future of space explorations. In order to appreciate and understand how we've made it this far, we got to do a quick rewind to the events that led to the Chandrayaan 3 mission. Now, moon missions can be categorized based on their different objectives. The first and most basic type is the flyby mission, where a spacecraft simply passes by the moon without orbiting it. But if the moon has to be specifically examined, we have the orbiter mission, where the spacecraft orbits the moon, which allows detailed study of its surface and atmosphere. Next comes the impact mission, which is an extension of the orbiter mission. Here a portion of the spacecraft is detached to crash land on the moon, collecting valuable data during its descent. Chandrayaan 1 was an impact mission fitted with an instrument called CHASE, or Chandra's Altitudinal Composition Explorer, which discovered water on the moon. The next type of mission is called the lander mission, where a part of the spacecraft is sent to the moon for a soft landing. It is called soft landing because part of the spacecraft that lands on the moon, called the lander, has to gently land on the moon without crashing it, and achieving this feat is extremely complicated. Also, these landers, usually massive in size, touch down on the moon and stay put without much mobility. So in order to overcome this limitation, we next have the rover mission, which deploys small robots with wheels named as rovers out of the lander that can move on the lunar surface, enabling direct contact with the moon and facilitating exploration. And then of course the final category is the human mission, where astronauts land on the moon venturing on its surface. So Chandrayaan 2 was meant to be a rover mission on the moon, planned for a soft landing with a lander called Vikram, which carried inside it a rover named Pragyan. But during its descent on September 6, 2019, lander Vikram's engine malfunctioned, causing a crash landing, and the mission was deemed a failure. After much controversy, the reason for its failure was attributed to an engine thrust imbalance, which destabilized the landing attempt. This led to the Chandrayaan 3 mission, which is more or less similar to the goal that Chandrayaan 2 had in focus, that is soft landing on the moon's south pole and deploying a rover. The mission's landing site is a 70 degrees south of the moon, home to numerous craters that always stay in the shadows untouched by sunlight. And here is the twist, the rover will get only one lunar day to conduct its experiments. One lunar day equals about a month on Earth, split into 2 weeks of daylight and 2 weeks of darkness. But to gather all the information required, the rover gets only 14 days, as the instruments in Chandrayaan 3 are not built to withstand the frigid lunar nights, where the temperatures can drop to minus 208 degrees Celsius. Now, just like in Chandrayaan 2, Chandrayaan 3 consists of 3 modules. The lander module called Vikram, named after the father of Indian space program Vikram Sarabhai, the rover module called Pragyan, and the propulsion module. The lander module Vikram weighs 1750 kg and the rover module weighs 26 kg. The purpose of the propulsion module is to take Chandrayaan out of the Earth's orbit and send it towards the moon. With the help of this propulsion module, the lander and rover got into the moon's orbit, where they were dropped for landing after reaching the 100-kilometer radius. The propulsion module will keep circling the moon for 3 to 6 months and will remain in the moon's orbit, where they will be used for communication purposes and for recording specific readings. Usually they are also equipped with an orbiter module, but in this mission there was no orbiter because Chandrayaan 2's orbiter is still working and was reused. Now coming to the best part of this mission, Chandrayaan 3 carries different payloads or apparatus which serves various purposes. The propulsion module is one payload, Vikram lander has 4 payloads, and the Pragyan rover consists of 2 payloads. The propulsion module is fitted with SHAPE, or the spectropolarimetry of habitable planet Earth. This remarkable instrument will actually study the Earth from the moon's perspective, analyzing what makes our planet habitable and identifying various components essential for life. Given the staggering count of over 5,000 exoplanets we have identified so far, SHAPE takes on the mission of differentiating between those which have the right conditions to sustain life and those that might not be so accommodating. Considering the vast distance of these exoplanets from us, telescopic observations alone can't provide a full picture. But we could examine the light emitted by the distant worlds. As we all know, the light we see falls in the visible spectrum. But there are also other types of light rays, and when these rays interact with an object, some gets absorbed and some don't. So SHAPE's role is to study the behavior of light rays originating from Earth, which will help us identify where light rays similar to Earth is coming from. Moving on, Vikram lander also consists of 4 very interesting payloads. The first instrument, RAMBA, which stands for Radio Anatomy of Moon-bound Hypersensitive Ionosphere and Atmosphere. Let me explain. Earth has a magnetosphere around it, which is a vast, comet-shaped bubble that protects us from harmful radiations coming from the sun and therefore plays a crucial role in our planet's habitability. But in comparison to Earth, Moon does not have a magnetosphere, so the charged particles of the sun falls on the Moon directly. So RAMBA will measure the Moon's plasma ions and electrons density, of which we do not have much data yet. This is done by melting tiny rocks on the surface of the Moon using a laser beam and analyzing the gas released from it. Next comes CHAST, which stands for Chandra's Surface Thermophysical Experiment, which will measure the thermal properties at the south pole of the Moon. This is important because the temperature on the lunar surface fluctuates a lot. During the day, the temperature is very high, and during night, it drops really low. So this data is invaluable to better understand the climatic conditions of the Moon. Say in the distant future, if we plan to start a human colony in the Moon, these insights are really important as we'll know how to better adapt to the Moon's harsh climatic conditions. So CHAST makes small holes on the surface of the Moon, and then the land in and around it is heated, after which the impact this heat will have on the Moon is studied. Next comes LRA, or the Laser Retroreflective Array, which uses laser to bounce signals from the Earth. This payload can measure the exact distance where Vikram has landed and the range of the Moon, which will help in making better calculations for future space missions. An interesting fact is, this instrument was sent in from NASA. Now let's talk about the payloads on the Pragyan rover. Pragyan has two instruments, LIBS and the APXS. LIBS stands for Laser Induced Breakdown Spectroscope, which will analyze the chemical composition of the Moon's soil with the help of light. This will help us to know more about the availability of various mineral resources on the Moon's soil. Next comes APXS, which stands for Alpha Particle X-ray Spectrometer, which will also study the soil in the Moon. This device is equipped with a radioactive element called curium, which will blast alpha particles in X-rays on the surface of the Moon, and its primary goal is in finding traces of magnesium, aluminium and iron. When Pragyan conducts all of these experiments, Vikram lander will be taking its photos. Now let us shift our focus to the bigger picture, that is how this mission will impact the global economy and the global future of space explorations. Chandrayaan 3's mineral resources discovery could mark the start of the Moon's resources utilization. By tapping into the resources available on the Moon, we could significantly reduce the cost of launching missions from the Earth. This can be achieved by carrying lesser resources from Earth and sourcing it from the Moon itself. Now think about that. The mission's invaluable insights could also set off a revolution in lunar mining. As we all know, the energy sources of the Earth are running out, and therefore countries all around the world are looking into alternate energy solutions. This is where helium-3 comes in, an isotope that is scarce on Earth but abundant on the Moon. Helium-3 could fuel advanced nuclear reactors and play a vital role in clean energy generation. Similarly, water ice detected in the Moon's polar craters could revolutionize space explorations by providing a potential source of water for future lunar missions. Water can also be split into hydrogen and oxygen, offering breathable air and even rocket propellant. Now beyond resources, the insights obtained from the Chandrayaan 3 mission is also invaluable for space-based manufacturing. That is, the Moon's low-gravity environment and vacuum conditions provide an ideal setting for producing specialized materials, which could facilitate continued exploration of the Moon itself and also scientific and economic activities in the vicinity of both Earth and Moon. Or they could even be imported back to the Earth, which could contribute directly to the global economy. This breakthrough might not only bolster ISRO's endeavors but also attract international collaborations and commercial ventures, thus stimulating India's space sector and economy while also cementing its international presence. Now, as we gaze into the future, after the Chandrayaan 3 mission, the next big step of our Indian Space Agency is Gaganyaan, which aims to develop a spacecraft that can take Indians to the orbit. And globally speaking, America's Artemis 2 is also planned for November 2024, where humans will be sent to orbit the Moon after a gap of 52 years. And in the coming years, China is also planning to send astronauts to the Moon. So as Chandrayaan embarks on its journey, it carries with it the aspirations of a nation, the hopes of a generation, and the promise of scientific revelations that will resonate across time. It's a continuation of India's legacy in space, a legacy that soars to new heights with every launch, every discovery, and every dream fulfilled. So as we stand at the beginning of a new lunar adventure, let us remember that more than a mission to the Moon, Chandrayaan 3 is a beacon that guides us to a future where the stars are within our reach and the universe an open book waiting to be read. Thank you.